Hi, my name is Scott McLean from transmusicmastery.com, and in this video I'm going to give you an overview of the Virus TI synthesizer, and specific model that I have is the Virus TI Polar. This is the Total Integration VST plugin that allows you to work with the Access Virus TI as if it was a VST inside the box. But what's happening is it actually uses the hardware through the USB interface to produce the audio signal and then routes it into the DAW through this VST interface. And what I thought I'd do in this video is just walk through similarly to how I've done in the other videos for Silent One and Massive, just do an overview of the synthesizer and demonstrate some of the features that it has. So the first thing we want to look at is how do we interact with the oscillators. There's this easy tab here. This gives us sort of the high-level filter access here, the filter, things that are commonly accessed. Typically, I don't spend a lot of time. Usually, I don't spend a lot of time on this page. I'm usually in these other tabs here with like oscillator, filter, the LFO, the modulation matrix. It does have an arpeggiator. It has predefined patterns, but there is a user pattern where you can work with different note lengths and just set different modulation amounts as if it were a step sequencer / arpeggiator. And then there's an effects, 2 effects tabs, and delay and reverb are on effects 2, and then some common internal stuff and then patch utility. But the main things we want to look at for this video are going to be the oscillators, the filters, and the modulators, and the effects. Okay, so the Virus has 2 oscillators. And right now I've got a init patch loaded, so let me just hold down middle C. In fact, I had enabled the arpeggiator, so it's going right now. So let me disable that, turned it off. And the way that the oscillator, the init patch is set up initially is it has both oscillator 1 and 2 mixed here through this balance fader. I'm going to bring it all the way to the left, which indicates that we will only hear oscillator 1. And if I want to change the waveform, I can do so by turning this knob. And this allows me to select between a sine, a saw, and in between it's a sine and saw mixed. So it gradually mixes more and more of the saw wave in until we reach the top, at which point it's a pure saw wave, sawtooth wave. And you can see the display down here as I hover over different knobs and stuff. This display window shows the specific parameter value. So if I had a pulse width, or if I had a pulse wave, I can change this pulse width with this control here. In fact, let me zoom in. So that's how we select different waveforms. Now, Virus does provide a number of wave tables. So this is the classic synthesis mode, in which case we have the sine, saw, and pulse capability. We can switch to, actually if we go to sine, within this classic mode we can select a triangle wave here and then mix it with a saw wave or go to pulse. And then also any number of basically just spectral waves. So I can click and drag up or down to change the waveform. So you can go through and hunt for that. And then it also has these other types of synthesizer modes. Hypersaw, this is emulating sort of a stacked supersaw type waveform. Each line here represents one saw wave. You can have up to 9 of them. That would be one saw wave. to detune them, we can use this control here. Okay, so we'll be doing this more in the videos where I program some of the sounds. Now, to change oscillator pitch, we can use the semitone control. It spans 4 octaves. Also, the key follow, that's tuning, typically won't adjust that, but it determines how the oscillator pitch tracks to the MIDI note. I'll reset that to normal. Now, another mode is wavetable. This is where it really gets interesting. We've got a lot of different wavetables here to pick from. This is similar to, if you recall from the Massive overview video, where Massive has a number of wavetables. Well, it's a similar concept here. In fact, I'm going to move this up because I think the wavetable menu was off the screen for a moment. So let me demonstrate some of these. Sine, that's just the sine wave. Harmonic sweep. Now what's happening, let me move this over so you can see these two displays clearly. What's happening when you have one of these wavetables, there's this interpolation. What's really going on is if I turn the interpolation all the way to the right, this maximum value, now you'll be able to hear the individual waves within this wavetable. Okay, but if we bring interpolation down, what happens is between those individual waves, it will sort of morph or interpolate a new one. It'll blend the two together to create a new wave, and a varying amount of the blending between the two based on this interpolation amount and based on this wavetable position control. So with it at 50%, or all the way to the minimum value. And we can modulate this, which can give us some really nice ability to modify the timbre of the sound dynamically over time. Something like that. So let's try another wavetable. I'll just demo a couple of these. Try liquid metal. Or sine rider. That's kind of cool for special effects. And let's take a look at another one. Let's try Robot Wars. Let's see, what's another one? Friction. Acetate. So you get the idea. There's a number of different waveforms to pick from, and it's just a matter of going through and experimenting with them. Evil. Let's listen to this one. Okay, so then it also has this wave PWM, which is basically like a pulse width modulation type treatment of the wavetables. So it'll create a copy with an inverted waveform and allow you to change the pulse width here, the difference between the two. So let's try that with Evil. And then you can detune the amount here. So that would be detuning the copy of the waveform. Okay, and then another couple different types here: grain, simple and complex, informant, simple and complex, and these are additional algorithms that it's a different type of synthesis where it looks at the wave, breaks it apart into smaller, what they call grains and formants. And let's just demo these real quick. Grain simple. So there's a formant shift control. And then if we do grain complex, it gives us more parameters to control. Pretty wild. Now we can go to formant simple. And formant complex. Alright, so that's the basics. Now, if we come back here to classic, and we'll go to sine wave, just reset this to a saw wave. Notice that it's a ramp up type saw wave as opposed to a ramp down. So just one thing to be aware of. So that matches what we see in Silent 1 actually. Silent 1 has a ramp up sawtooth waveform. And notice also how that's different from the diagram that's shown here, the graphical display. So I thought that was kind of interesting. Now, so if we look at the number of oscillators, it has 2 oscillators plus this third oscillator, which can be configured to be a what they call a slave, and that means it's basically taking all the parameters from oscillator 2 and matching it. Or it could be a different waveform, like a sawtooth wave, a pulse. You don't have as much control over oscillator 3 parameters like you do with oscillator 2 or oscillator 1. Or it could be any one of these wave slots here. Okay, the other thing we have is unison. We have the unisono mode. We can double up the voices, so let me demonstrate that real quick. So we can detune the voices against one another or spread them out via panning, which will give a wider sound. And then there's also the ability to spread out LFO treatment as well on these voices. We can have up to 8 voices, so let's do sounds pretty good. And punch, this adds like a pop to the beginning of the sound. Then there is a noise generator as well. So if we bring this volume up, then this control becomes enabled, and we can now adjust the color of the noise. Okay, you get the idea on that. Let's get that down. We also have a ring modulator. Let me turn the volume up. Now, the basic idea is we want to look at how the oscillators route to the filters, and basically they're mixed together, blended together, and flow into the filters. So we'd have the sub. It also has a sub oscillator. Forgot to mention that one. So if I play like middle C, and you can change the waveform type for the sub with this switch here. So you could have a pulse wave, or a square wave, or a triangle wave, depending on what you want. But getting back to the routing, so basically the oscillator, the noise, the signal is generated and then flows into the filter module. And the filters, there are 2 filters, okay? And you can change the routing. They could be what's called serial 4, and that is in effect a 4-pole filter. This would make filter 1 a 2-pole filter, which would be 12 dB per octave. And filter 2 a 2-pole filter, which is 12 dB per octave. And then there's a display here that shows the routing. There is saturation, so we can saturate the signal, which adds some distortion. So if I select hard for saturation, right now my oscillator volume is at maximum, but I can continue on into the saturation zone. And you can see how that waveform shape had changed over here based on that saturation. So let me move this over a little bit. Watch over here as I play and move this saturation back down to where there is no saturation. Okay, that can be useful for giving the patch a little bit of an edge, help it cut through the mix a little more as we add some saturation. The filter types: low pass, high pass, band stop. So we've reviewed those. And the analog mode, that's a special filter mode only available on filter 1, and this gives us sort of a old analog style filter, mini Moog style actually, and it can be a 1-pole, 2-pole, 3-pole, or 4-pole filter. Let's give it something to bite into. Okay, and then we have sort of a pre-wired modulation for filter 1. It has its own filter envelope, and the amplifier has its own filter envelope here. We also can see some sort of convenience knobs here for velocity, controlling how much of the velocity modulates the resonance and how much velocity modulates the envelope amount for the filter. And this plus switch determines whether the filter 1 envelope polarity is positive or negative. So if we wanted to, we could bring cutoff here and then apply some modulation via the filter envelope. And then have velocity modulate that envelope amount. So the harder I hit the key, the higher the envelope amount will go. Reset those to 0. And then the filter routing, we can just have the signal go through filter 1, or we can have the signal go through both filters. The input routing would be controlled up here, and then the filter balance is whether we hear the output from filter 1 or filter 2 or both. So another routing is what they call serial 6. This is 4-pole on filter 1, then through saturator, and then a 2-pole on filter 2. Or parallel, it would be filter 1 would be 2-pole, filter 2 would be 2-pole, and then both of those combined go through the saturator. Or split mode, which is kind of interesting. Oscillator 1 would go through the 2-pole and then the saturator, and then oscillator 2 would go through the 2-pole. And I would skip saturator. So experiment with these different routing modes to get a feel for how they work. Okay, the envelopes, the user interface for the envelope actually makes it pretty easy to work with. We can click on the envelope, drag and drop, and increase or use these knobs. Same thing with the amplifier envelope. Sort of a pad envelope there. Okay, let's go to the LFO section. Pretty typical of what we've encountered so far. One thing to note is it automatically gives us sort of pre-wired destinations or targets for LFO modulation. So there's 3 LFOs, LFO 1, 2, and 3. And if I wanted LFO 1, it's already pre-configured to modulate the pitch of oscillator 1 or 2, pulse width of oscillator 1 and 2, resonance of the filter 1 and 2, or the filter gain. And then LFO2 is set up to already have target destinations of filter 1 and 2 cutoff, the wave shape. This is kind of cool if I wanted to come back over to the oscillator and modulate this wave shape. Let's switch to one of the wave tables. Let's say I wanted to modulate this so it goes back and forth like this with an LFO. I can come over here to LFO2, use this control here, and this automatically assigns shape 1 and 2 as the target of the LFO modulation based on this amount. So that gives us a convenient way to achieve some timbre variation dynamics in oscillator 1 and oscillator 2. And then finally there's this LFO number 3, which gives us the ability to assign to any of these destinations. Now we can also use the modulation matrix, which is very similar to what you saw with Zebra 2 in the Zebra 2 video. We can select a source. Any one of these sources can act as a modulation source on any of these 6 slots. And then we can have up to 3 destinations. And pretty much almost anything on the synth can be modulated. Quite a few options here. I already looked at the arpeggiator, the effects, number of different what they call characters, which allows for shaping the overall sound that's coming from the synthesizer. So this analog boost, let's take a look at what that does. If we go back to classic sawtooth, and let me go back to a single wave, reset the filter. Actually, I'm just going to drag and drop this guy. So now I just reset to the init patch. And let me return the oscillator balance to 1. So now we only hear oscillator 1. Okay, let's go back to effects 1 and adjust this analog boost and see if we can tell what it's doing to the waveform. So this can be used to alter some of the harmonic content and the wave shape. There's also these other character modes. Let's check those out. So that could help affect the tonality of the sound. Fairly sophisticated distortion unit here, a lot of distortion options. fact, let me return this to analog boost. These mint, curry, saffron, these and onion, other ones emulate some of the stomp boxes that guitar players use. These are pretty neat. Each one has its own character. And let's see, it has a chorus, a phaser, frequency shifter. This is kind of cool. It also has a comb filter, actually. I ended up updating to the latest version, and it does have a comb filter. Works a little different than the Silent 1 or the Zebra 2 comb filter, because remember the Zebra 2 had that feedback, and that allowed us to get that natural decay of like a plucked instrument or something. You'd have to use this comb filter in combination with the envelope over here to achieve a similar type tone. Then an EQ with low, mid, and high. And I'll be using that actually in the other videos. And then delay and reverb, and you'll see me use these in the other videos, so I'll just save those for there. That's really about it. So that's it for the overview. I'll see you in the next video.